Hello, I'm Arnaldo Laborda, the CEO and founder of ASVAD. My purpose with this presentation is to warn you about the nitrogen injection problem and to explain why nitrogen is a risky threat to our reactors. I will discuss the FSG-10 guide written by the Westinghouse Owners Group to cope with this issue. We all use this guide at our plants. Lastly, I will present the ASVAD valve, a brand new solution to this issue and the best one available. My purpose is to take no more than 15 minutes, so I'll go fast across the slides. You're experts, and I'm sure you don't need in-depth explanations to understand the slide. I'm proud to share that our valve was recently awarded an important prize from Euratom. This award is the proof of their exceptional qualities. Okay, let's go. As experts, you're familiar with all these concepts. You know the standard nuclear accidents and their expected progression. You know the important role of the RCP seals and also the copying strategies. You also know the important role of the accumulators. And probably you already know why its nitrogen has to be kept away from the RCS pipes. Because this nitrogen heavily disturbs the core cooling. You also perfectly know that nitrogen will stop the natural circulation flow, stopping the core cooling and strongly degrading the steam condensation in the SGs. This nitrogen, heated by the steam rising from the core, will raise the RCS pressure, increasing the leak rate and hindering the emergency pump's work. But you probably ignore that this nitrogen will strongly accelerate the oxidation of the fuel cladding. Metallurgic studies done in the prestigious laboratory of Karlsruhe in Germany show how the zirconium cladding is oxidized by different concentrations of nitrogen in water. Just 1% of nitrogen is enough to clearly degrade the cladding. The more nitrogen, the more degradation. These pictures are terrifying. Nitrogen will shorten the time available before the fuel damage. Why is nitrogen a threat? Because this injection is likely to happen. Why can I say that? First, we have to point out that this nitrogen is already inside the system, and there is a big quantity, more than 600 kilograms at each accumulator. If nothing is done, it has an open and direct path to the core. And the worst, as this nitrogen is pressurized, it is always trying to get into the pipe. It just needs a moment of low pressure in the core to get into the pipes. And during the accident, the pressure is permanently decreasing due to the leak. So it's a simple matter of time until this nitrogen reaches the system. As far as I know, this issue is not considered in the probabilistic risk assessment. Why? Why is this risk dismissed? I don't know why, but I'm very concerned about it. It's time now to talk about the FSG-10 strategy that provides actions to try to prevent nitrogen injection. This guide gives only 2 strategies. The first one is to close the accumulator's output isolation valves before the water injection ends. To achieve this, we have to deploy a flex generator, powering the valve controllers and closing all the isolation valves, one by one, but only at the correct moment, not too soon, not too late. Because if done too soon, it will be water wasted inside the accumulator. If too late, nitrogen will get into the pipes. A second strategy is to vent the residual nitrogen to the atmosphere by the accumulator relief valves. As these valves are usually pneumatically operated, you also need to deploy a flex compressor and then try to open the valves. But as the air pipes are not designed to withstand this kind of accident, this air probably ends at the containment without moving any valve. Finally, there is an additional strategy to keep the RCS pressure over the nitrogen pressure. To achieve this, we also need a flex pump, injecting water to maintain the pressure. However, this is just a temporary strategy, trying to get more time.
Sooner or later, the RCS will be further depressurized, and then we will have to use one of the two previous strategies.
However, these tactics all share these common flaws. All needs from the operator's work, so it needs human actions. A lot of action. They have to do multiple and simultaneous actions at every accumulator. These operators are forced to take important decisions as to what strategy is the best, and, more importantly, when and how to develop these actions. Obviously, all the equipment needs power. No power, no strategy. All this equipment used by the strategy are active elements. All have to work properly and have to be managed by the operators. Failures are not allowed. But this is not the worst. All these actions must be done at the correct moment, not too soon nor too late, because they are all time-critical actions. Focusing on the isolation valves, they will leak nitrogen even when closed because they are designed to isolate liquid, not gas. And these valves are never leak tested. As for the air pipes, we can't rely on them because they are not designed to withstand the accident. About the last strategy, it's just a temporary strategy. All these strategies give an important burden to the already stressed operators. Now, I'll point to the FSG 10 guide, which is relying on these assumptions. The first one, knowing the correct moment to act. Operators will have to decide when the strategy starts, usually with poor information. Also relies on having enough time to perform the strategy over all the accumulators. This means that the strategy has time-critical actions. The second one, it also relies on the deployment of the active emergency equipment and their proper actuation. No failures are allowed. Finally, it also relies on the proper organization actuation and its capabilities to perform the work. These are the organization efforts. All these elements are needed to achieve success. Knowing all of this, do you still trust it? This is a chain of actions with multiple and active elements. Every link in the chain must work properly. The chain is as strong as its weakest link. Just one failure, it means nitrogen injection. Fortunately now, the ASVAD valve will help us to solve this problem. Here it appears. Knowing all these weaknesses, we decided to solve it by designing a new element, the ASVAD valve. To the weakness of deciding when the strategy starts, we have designed an automatic valve that decides by itself the correct moment to act. To the weakness of having enough time to perform the strategy, we have designed a valve that acts in a few milliseconds. This means fast action. We can forget about the time. To the weakness of deploying a lot of active elements, we have designed a valve that will already be installed. This valve is fully passive and the only one needed to cope with the nitrogen. This means a passive element. To the weakness of using human operators, we have designed a valve that does not need nobody. Nobody will have to take a critical decision. Nobody will have to do any action, and it always will be ready to act. This means fully automatic. With all these three characteristics, now success is guaranteed. Are you intrigued about how this valve can be? You will be surprised to understand how a simple design can accumulate all these good characteristics in one simple body. Okay, it is time now to introduce the ASVAD valve. ASVAD is our simple solution to the nitrogen injection problem. ASVAD is the acronym of Automatic, Safety, Valve or Accumulator, Depressurization. It is easy to remember. But what is ASVAD? ASVAD is a safety valve specifically designed to avoid the nitrogen injection. Unlike the standard relief valves, ASVAD has the opposite behavior. It only opens when the pressure drops below a specific set point. It's a very simple valve, less than a dozen pieces made in stainless steel. There is a simplified view of the valve, and this is the real view of the valve, our last design. This valve is fully passive, very simple, hard, and you will see that it is also very reliable. All the benefits are condensed in one durable body, where ASVAD is installed. This is a simple diagram of the accumulators. The ASVAD valve is installed here in the nitrogen side of the accumulator. It only needs a manual isolation valve for maintenance purposes and a few feet of pipe. This makes its installation very easy and cheap, as no big modification is required. Now the most interesting slide. It explains how the ASVAD works. You will understand easily because it is a very simple concept. At the bottom side is the pressure chamber, and at the upper part is the mechanism side. Between them there is a hollow obturator in blue. This obturator seals the chamber. Their operating principle is the imbalance between two forces. First, the force done by the nitrogen pressure at the bottom side of the valve, the big red arrow. This force firmly pushes up the obturator, closing it. The second force is the force done by a spring, the small red arrow. This force pushes down the obturator against the pressure. During normal operation, the upward pressure force is 3 times bigger than the spring force, and then the valve remains permanently closed. But during a LOCA accident, when the RCS pressure drops below the accumulator pressure, its injection starts, sending its water to the core. As the water comes out from the accumulator, the nitrogen expands and its pressure drops. When the accumulator becomes empty of water, his pressure is not strong enough to overcome the spring force, and suddenly the obturator is pushed downwards. This displacement opens a direct path across its hollow center and discharges all the residual nitrogen to the atmosphere. This is the main function of the valve, to exhaust the nitrogen only when the accumulator gets empty. It's so simple. This is a short video about the ASVAD behavior. You can see in the lower manometer how the pressure drops, until the valve suddenly opens and exhausts all the nitrogen. As simple as this. I'm sure that now you will guess what the main advantages of ASVAD are. The first one is that the valve is available all the time because it's already installed. It's just waiting for its moment to act during all the time. If ever its work is needed, the ASVAD valve will fully avoid the nitrogen injection without needing any external energy to work, and also without requiring any operator assistance. ASVAD will do its action at the correct moment and over all the accumulators. The valve automatically acts, sensing the accumulator's residual pressure. Once actuated, it completely vents the accumulator. No further delayed nitrogen injections are possible. Operators will not be burdened with this issue, and they can concentrate on other more critical recovery tasks, thereby saving the organization's efforts. But in my opinion, could the main advantage of this valve be that avoiding the nitrogen problem? RCS can be depressurized from the current high pressure, near 300 psi, to lower pressures like 100 psi. This further depressurization will greatly facilitate the accident recovery, allowing more time and fewer problems to keep the cooling. Now you will be able to inject water even with a garden pump. Could this last advantage be their most valuable advantage? Other secondary benefits are that it's a very stable valve. It will remain fully closed during the normal operation. Its robust and simple design that means high reliability. This valve is made of steel, no problems working under harsh conditions. Its installation can be very easy, as you have seen before. It's easy to be licensed because it doesn't add any new failure mode. Our Spanish regulator gave us his approval in January. No electromagnetic problems, no software, no cyber attacks. Obviously, this is a joke, but it's true. ASVAD is qualified as a nuclear Class 2 valve. All the accumulator system is Class 2 because it's not RCS pressure boundary. It can be remotely actuated, but this is an option not usually required. It's easy to maintain. There is no wear in the valve. The maintenance cost is minimal, just like another standard relief valve. Just changing its gaskets every 9 years. Install and forget. It's easy to be tested, both functional and leak tested. It's easy to be adjusted to the desired pressure actuation. It can be cheap because it doesn't need an expensive modification. Finally, its high qualified life means that no further investments will be required. Buy once, use it forever. This slide is about how reliable their opening point is. This was one of the multiple tests done during its validation. It shows 5 runs with the pressure decreasing until the valve opens, near at the same point all the times, 17 bar with a really few dispersion. This behavior obtained the approval of our Spanish nuclear regulator. This slide is about the design basis accident test. The ASVAD valve did its job after 4 days of harsh ambient conditions, surpassing the standards. This is easy to understand, as the valve is fully metallic. This makes it very insensitive to any harsh environment. This allowed ASVAD to easily fulfill the ASME requirements to be a nuclear Class 2 valve. It will be easy to be Class 1, but not needed. I've reached the end of the presentation, so it's time for the conclusions. Our first conclusion is that the nitrogen injection is a risky threat to the core integrity. It is our inner enemy. Our second conclusion is that the FSG-10 strategy is too weak to rely on. Finally, the ASVAD valve is our reliable solution to avoid the nitrogen injection. Remember, this valve has deserved the Euratom Award. Now, a simple allegory after the conclusions. Nitrogen is like a missile that is targeting right to our RCS veins. The FSG-10 strategy is like a giant with feet of clay. Too much effort from the organization, too many active elements, and time-critical actions. Fortunately, now we have the ASVAD valve, our best passive protection. It will be like a hard wall to avoid this risky complication. The animation is very descriptive. We've reached question time. I can understand that probably you are not the right person responsible to take action on this issue, but I'm sure that you know who the person responsible to manage this issue is. You know, safety is not built from words, but from facts. While you don't take any action to resolve this issue, the nitrogen risk will be present at our plants. These actions can be as simple as asking the responsible person about that and sharing with him this information. Are you going to do something? What is Westinghouse Group going to do? Now is your time to take action. At least ask Westinghouse about nitrogen. This presentation is simple to understand. I hope there are not many questions. Anyway, I'll be available in our email or website to answer any question. This is all. Thank you for your attention. I hope you've enjoyed it. I'll stay here, waiting to see what you do about it. Bye-bye.